Today we are going to discuss two problems from the chapter Refraction Through Lens. These problems have been taken from the Conscience Physics book class 10 SSC. Okay, so let us see what are the problems given here. First of all, let us come to the solution of problem number 1. What the problem number 1 says? It says at what position a candle of length 3 cm be placed in front of a convex lens so that its image of length 6 cm can be obtained on a screen placed at a distance of 30 cm behind the lens. Okay, so first of all, just let us try to understand what are the things given here. First of all, see, it has been said that the candle length is of 3 cm. Okay, so 3 cm candle length means this is the object height. So if you have remembered the sign convention as we have discussed in the lectures of the lens chapter, the object height is always positive, denoted by the letter O. So here the object height is 3 centimeter. So let us write it. Solution 1. Okay, fine. So the solution 1 says that okay, so the object height has been given. So object height has been given. Object height is denoted by letter O. It is given as 3 centimeter, and object height, as we have discussed, is always positive for any kind of lens. Okay. Next, what is the another thing given here? At what position a candle of length should be placed? So we have to actually determine the position of the candle. That means that we have to determine the object distance. Okay, the image length is given to it 6 centimeter. Image length means it is the image height. So second thing that has been given here is the image height. So image height is denoted by the letter I, and it is given here 6 centimeter. Okay, now should it be positive or negative? How can we determine that? See, where the image is forming, the image is said that it has been obtained on a screen placed at a distance of 30 centimeter behind the lens. Behind the lens means on the other side. If the object is at the left side of the lens, then the image obviously is formed on the screen, and the screen is placed at a distance of 30 centimeter behind the lens, means on the right side of the lens. So obviously this image that has been formed is actually a real image, because virtual images are formed on the same side as that of the object, but here the image is formed on the other side at which the object is placed. So definitely this is a real image. Now real images are always inverted, and inverted means the object height should be negative. So 6 centimeter, this is negative. Okay, fine. What else has been given? Say this position of the screen has been said, so it is the image distance that has been mentioned. Image distance, position of the screen means image distance, because the image is formed on the screen. So this is the image distance denoted by letter V. Now it is said to be 30 centimeters. See, it is said to be 30 centimeters, and as it is formed on the other side of the screen, hence the image distance is actually positive. Okay, fine. Now let us come to the solution. So what you have to find out here? We have to find out the, see, we have to find out the focal length, and previously to that we have to find out the object distance. Okay, fine. So we know, so let us consider the object distance to be u. Okay, so let us consider the object distance to be u. Let us consider the object distance to be u. We don't know whether it will be positive or negative. We will find it out from the calculation. So we know that there is a formula for magnification. If you remember, there is a formula for magnification. Magnification is denoted with the letter m, and magnification for a lens is given by I by O, that will be equal to V by U, isn't it? Okay, So the magnification, we do not know the magnification, but we know the other three values I, O and V. We have to determine U. So from this equation, therefore if I put the values of I has been given as 6 minus 6, so let us write minus 6. O is given as positive 3, so plus 3, equals to V has been given as plus 30, and we have to determine what is U. So U, so from this we can say what will be the calculation, 3 and is simplified as 2, then U, this implies that U will be given as 30 by minus 2, that means U is minus 15. So what does the negative sign implies? Negative sign implies that the object is placed behind the lens, sorry, in front of the lens, that is why it is coming out to be negative. So object distance is 15 centimeter in front of lens, therefore object is 15 centimeter in front of lens. You have to write it like this, okay, in front of lens. Fine. So the first part of the problem has been solved. Now the second part says what is the focal length. So you know there is a formula for focal length, isn't it? So what is the formula for the focal length? So you can say formula for focal length is, what is the formula for focal length? 1 by f, we know that. So the second part, if the focal length is considered to be f, let us consider the focal length to be f. We will be doing the calculation on the just right part of the solution. So if I consider the focal length to be f, so focal length will be 1 by f, isn't it? So 1 by f will be equal to 1 by f will be equals to 1 by u, 1 by v minus 1 by u, isn't it? We have done this formula, we have viewed this formula in theory class, 1 by v minus 1 by u. Okay, so v is given as positive 30, so it should be 1 by 30 minus of 1 by minus 15. Okay, so taking this into consideration, so it will be plus 15. Okay, now if I consider the LCM will be 30. Okay, so it's 1 plus 2, so it's 3 by 30, 3 by 30 and positive, so this turns out to be 1 by 10. Hence the f is given as f is equals to plus 10. Okay, therefore the focal length is plus 10 centimeter. So focal length is equals to plus 10 centimeter. Why it is coming out to be positive? You know that for a convex lens the focal length is positive. See, in the question it has been given that the convex lens is having mentioned convex lens, so obviously the focal length will be positive, that's why it is coming out to be plus 10 centimeter. Fine. Okay, so now let us come to the solution number 2. Okay, so solution 2. So what does the question number 2 says? That a lens forms the image of an object placed at a distance of 15 centimeter in front of it. So object distance has been given as 15 centimeter, it is taken to be negative, so just let us write it down. Object distance is given by the letter u. Okay, so object distance is how much it is given? It is given as 15 centimeter. So 15 centimeter is 15 centimeter. Fine. Next, what is the way? So in front of it at a distance of 16, okay, the lens forms the image at a distance of 16 centimeter, 60 centimeter in front of it. So image distance has also been given, so this is negative object distance, image distance is 60 centimeter. image distance is 16 centimeter. Image distance given by the letter V, it's 60 centimeter. 60, not 16, rather 60. It should be positive because it is found on the other side of the lens. Fine. So what you have to calculate? You have to first calculate the focal length, magnification, and nature of the image. Okay. So focal length, we know, if we consider the focal length to be f, focal length, let us consider this to be as f. Okay. So for the focal length, what will be the formula? 1 by f is equal to 1 by v minus 1 by u. So 1 by v means 1 by 60 minus 1 by minus 15. So this is the formula. So this turns out to be 1 by 60 plus 1 by 15. If I do the LCM will be 61 plus 4, hence it turns out to be 5 by 60. Therefore f is equals to, how much it becoming? 5 12 is 60, isn't it? So 12, positive 12. Hence the focal length is, focal length, every length is given in centimeter, so the focal length is 12 centimeter positive. Okay. So obviously the lens, next what you have to find out, the magnification. Okay. So there can be another question. What can be, it can be also asked that what is the nature of the lens. So see here, the focal length becomes positive, isn't it? So if the focal length is positive, remember, obviously you have done this in the theory class, then the lens is actually convex in nature. If the focal length is negative, it is concave in nature. Okay, second thing that you have to find out is the magnification. Now the formula for magnification. Okay, the formula for magnification is, what is the formula for magnification? Magnification is given as, magnification is given by there are two formulas. What we will be using here is v by u, because we know the values of v and u. So v is say 60 plus and u is minus 15. So 60 positive and u is minus 15. So m turns out to be minus 4, isn't it? Okay. So we obtain the value of the magnification. This is the second part. This was the first part. Focal length was the first part. This is the second part. And the third part says what is the nature of the image. Okay. So what is the nature of the image? Now see, the magnification is minus 4, remember. So we have discussed in the theory class. If you have not seen the theory class, please view it once again. You will be able to understand why you are calculating the magnification like this, and what is the conclusion that you can draw from the value of the magnification. See, since the value of the magnification, see, the value of magnification is minus 4. If we consider just the numerical value, it's 4. So 4 is obviously greater than 1. So the image is obviously a magnified image, as because the magnification value is 4. So if I consider only the value, numerical value, if it is greater than 1, then it's magnified image. So first is the image is magnified. So nature of image, if I consider nature of image, first of all, it is magnified, as because the value is 4. We are seeing the value without the sign. Next, since the value is minus 4, see, magnification is also given by the formula I by O, image height by object height. Now object height is always positive, so the value of magnification will be positive or negative. That depends on the image height. If the image height is negative, then the magnification will be negative. See here, the magnification is negative means the image height is negative. Image height is negative for which kind of lens? Image height is negative for the convex lens in where the image is inverted. So second point is that it is inverted. Okay, and inverted images are always real. So third point is real. So it is real, inverted, and magnified. Okay, so this is the nature of the image. And just extra information to be given, you can also say that the nature of the lens, nature of the lens is, this is not mentioned in the question, I'm just discussing it separately. Nature of lens will be convex. Why? See the value of the focal length positive in nature, hence it will be convex lens. Okay, so this is the solution. Fine, so we will be stopping here. Okay, we will be discussing the some more problems in the next class. Okay, so till then, thank you, goodbye.